please turn again in your books to page 76, and I need somebody to read what can rate of change represent. Who would like to read for me? Who wants to read? Go ahead. Why don't you read for us? Top of page 76.
Today you'll focus on the meaning of rate of change in various situations. What does the rate of change represent? How can you use it as you graph the results of a competitive bicycle race today? Think about how the participants' rates of change compared to each other.
Okay, great. So we want to know, what does rate of change represent? So keep this in the back of your mind. And what does rate of change mean in various different situations, which we'll discover today? And how can you use the rate of change, as well as how do rates of change within a given real-world example affect each other? So go ahead and also read the big race, Heat 1. Oh, before you do, some of you are athletes, so you recognize when it says heat. So you go to, for instance, a cross-country meet, because we're in cross-country season, and there are different heats. Or like in track, there are so many athletes, like in the 100 meters, that they will have different heats. So they'll have like a first heat, a second heat, and a third heat. And so they divide up the athletes by male and female, and then they try to group them according to who has the better times, okay? That's what it means by heat, so go ahead. So there's different events for the same thing.
Before a big race, participants often compete in heats, which are primarily races that determine who competes in the final race. Later in this chapter, your class will compete in a tricycle race against the winners of the
Preliminary, yeah.
heats.
Okay, and keep going.
In the first heat, Leslie, Christine, and Amy rode tricycles towards the finish line. Leslie began at the starting line and rode at a constant rate of 2 meters every second. Kristen got an 8-meter head start and rode 2 meters every 5 seconds. Amy rode 5 meters every 4 seconds and got a 6-meter head start.
Okay, that's really important information. Then just read A for us and we're there, okay? Read A.
On neatly
Thank you.
scaled axis graph, and then write an equation in terms of x and y for the distance Leslie travels. Let x represent time in seconds and y represent distance in meters. Then do the same for Kristen and Evie using the same set of facts.
Okay, on your graph paper right now, this is what everyone's doing, all right? Everyone go ahead and pull out your graph paper. I want everyone to turn your graph paper horizontally, okay? Turn your graph paper horizontally. And let's see how I can bring this down. I think it all has to do with height, doesn't it? Nope, it's got nothing, it's the projector. All right, well, it is what it is. Okay, so I'll start at the bottom. Let me see. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I can barely reach that high. Okay, you're doing this again. Do this horizontally, all right? So draw this horizontally, and I think I'll take it. So give yourself 20 on the height, and let's see if we can go over about 30 on the width, all right? So go ahead, and this is your y-axis, of course. 1, 2, 3. I'm just going to go over here a ways. And this is your x-axis. So everyone should be following along doing this right now. Okay, so we have our x-axis and our y-axis. And let's, they tell us how to label it. This time they're telling us how to label it. Yeah, Michael? I'm getting there. Okay, so you're going to go 20, leave 20 for y. So let's go ahead. 1, 2, 3, 4, 5. I'm going to, instead of labeling each one of these in increments of 1, which they are, I'm going to label them in groups of 5. Yeah, it's, okay, so 1, 2, 3, 4, 5, right? 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so I'm labeling them in groups of 5, but notice they are in increments of 1. Is everyone fine with that? We're going to do the same thing on the x-axis. So we're going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and my 24 is right on that bar in between my 2 whiteboards. So 21, 22, 23, 24, 25 right here. All right, 1, 2, 3, 4, 5, yeah. 26, 27, 28, 29, and 30. Okay, so we got it there. All right, let's see what they wanted us to label. What did they say to label the x-axis, everyone?
Time in seconds.
Okay, so here we're going to go ahead, we're going to call this time in seconds, and we're going to call this, what did they tell us to label the y?
Distance in meters.
Okay, distance in meters, and I'm just going to put it like this. So distance in meters. All right, so there we have it. All right, so I'm going to give you a few minutes. Everyone get it labeled that way. Again, please have it. Can I borrow yours? This is excellent, okay? See how she's doing this horizontally? That way you're going to fit everything on. If you try and go vertically, it's not going to go 30 across. That's why I did it horizontally. All right? All right, so let's see what the first one, what did it tell us about Leslie again? Leslie, it said, began at a starting line and wrote at a constant rate of 2 meters.
Every second.
Yes, every second. That's a good point.
So it's 2, 1, 2, 1.
Very
2,
good.
1.
That's right. And she's starting at the starting line, right? So here we are. This is our starting line. And so she's going up 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. Thanks, Garrett. 1, 2 over 1. So I'm going to do this all the way up. So again, I'm just starting from 0. You're up 2 over 1 because she's going 2 meters every 1 second. So up 2 meters over 1 second. Up 2 meters over 1 second. And so just again do that all the way up until you hit like around 20. All right, and now I suggest you use your book as a straight edge, and I'm going to use a meter stick. All right, so we can, and am I gonna cross over this intersection here of the origin? Will I cross over the origin?
Yeah.
I will? This is a race. Is it possible to
You don't
race?
cross over it, you just start at
Right, I start at it. You can't race, you can't go anywhere a negative amount of distance, but that's a good thought. Okay, so I appreciate, that's right, we don't cross over it. All right, so here we go. Let's go ahead and connect those. So I'm starting at my origin and I'm right there. Again, use your straight edge of your book. Okay. All right, so, oh, thank you very much, Ray.
But if I go straight edge, because as you can see, I'm
Oh, that's fine. Yeah, that's totally fine. Just, or you can eyeball it because you're just connecting the dots, right? Okay, so what are we told about, who's our next individual? Kristen? What are we told about Kristen? Somebody read me what it says about Kristen right there. Read on page 76 what it says about Kristen. And switch colors for Kristen, guys.
She got an 8-meter head start and rode 2 meters every 5 seconds.
Okay, very nice. So Kristen gets an 8-meter head start. So where do
She
I
starts
start?
at 8.
Yes, that's very good. She starts at 8. So 5, 6, 7, 8. This is her starting point, and she is going 2 meters. So we're going to go up 2 every 5 seconds. 1, 2, 3, 4, 5. Up 2 meters over 5 seconds. 1, 2, 3, 4, and 5. It's over and over. Up 2 meters and over 1, 2, 3, 4, 5 seconds. Up 2 meters, 1, 2, 3, 4, 5 seconds. Up to 1, 2, 3, 4, 5. Let me make sure I'm on the 5. I am, good. And then up to 2, 3, 4. Okay, I think that's plenty. Let me get my straight edge on that. Okay. Through my 8. Whoops. We'll get the idea though. All right, and then after Kristen, I believe we had Evie. So I should label these. This is Leslie, right? Isn't Leslie the first one? Okay, great. Leslie, and was it Kristen the second one? Okay. This is Kristen. And then, let me get that back up.
Turn on the auto clicker.
Yeah, that's fine. What?
Turn on the auto clicker.
Okay, yeah, I will in just a second. I'm going to keep going with this. Okay, so, Evie. Evie's our next one. I'll put Evie in maybe green. I think I need a green pen. All right, so what is Evie's rate?
She starts at 6 meters because a head start.
Okay.
Then 4 across, 6 up. Sorry, 5 up.
Okay, so Evie is writing 5 meters every 4 seconds, and she gets a head start at 6. So that's correct. Our y-intercept then is 6. Thank you very much. Appreciate that. We're on page 76. Just go ahead and grab a book. Okay, that's totally good. All right, page 76, we're on this heat is what we're on, the big race. Okay, so Evie has started at 6 seconds and, 6 meters, so she gets a head start. We're told that she goes 5 meters every 4 seconds, is that right? Yes? Okay, so we're gonna go 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4. Okay, again, she's going 5 meters, 1, 2, 3, 4, 5, every 4 seconds. 1, 2, 3, and 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, and I think that's plenty for me to do my straight edge. Yeah. So I make sure. Okay, it would help if I was taller, but we'll work with it. All right, and this is Evie. Okay. All right. Now, I'm sure they're going to ask us a series of questions. Let's see what they want to know. Let's see. Nico, could you read B for us? Oh, wait. Did we do everything on A? Let X represent time in seconds and do this? Yes, we did. Nico, could you read B on page 76, please? Yes.
After how many seconds did Leslie catch up with Evie? How far were they from the starting line when Leslie caught up to Evie? Confirm your answer I don't know how to say that.
Algebraically?
And explain how to use your graph to justify your answer.
Okay, so the first thing I'm going to ask you is, here's a race, and guys, who would you rather be? Would you rather be Leslie, Kristen, or Evie?
Leslie.
Leslie, you'd rather be Leslie? Any differing opinions?
Kristen.
You guys would rather be Kristen. Some people would rather be Leslie. Okay, let me ask you why you would rather be Leslie.
I'd rather be Leslie because she's going up at a faster rate instead of on Christian. Yes, he started ahead, but he's going like this. Well, Leslie is going like going upstairs super fast, while Christian is
Super fast.
going up like
Super slow.
Super slow.
the old Coliseum steps,
Old Coliseum steps, I like
Best
that.
think I could come up with.
No, that's good. That's good. I like that. Okay, so some of us would rather be Leslie. Some of us would rather be Kristen. Does anybody want to be Evie? You'll be Evie. Well, why? Why do you want to be Evie? You need to know why. He wants to be Evie because he feels like Evie is left out. Is that it? So, okay, well, thank you. Well, let's evaluate whether the advantages of being one individual over another. Now, I've already heard some great things. Leslie is going at a faster rate. So I had some individuals that changed their mind, said, well, yeah, Kristen she did get a head start, but she's going at a significantly slower rate. So, let's say this big prize at the end of this race is like $100. Who would you rather be then? Who? Leslie. Okay. Yeah, okay, good. And Leslie is then, of course, the winner. So let's go ahead and evaluate. They want us to know, I already forgot the question. B. Okay, I know, it doesn't stay for me either. How many seconds did Leslie catch up to Evie? Okay, so how many seconds did Leslie catch up to Evie? Oh, thank you. So on this, you can turn over and put the answers to your questions on the back. So this is, maybe I'll write it in black. So this is 52B. 52B. All right, and then again, it's asking us after how many seconds did Leslie catch up to Evie? Okay, well, let's look at Evie and let's look at Leslie. How many seconds did it take her to catch up? 8, very good. So after 8 seconds, we can say Leslie caught up to Evie after 8 seconds. Good. And they were both going then how fast at that point?
16 meters.
Yes, 16 meters right here. Took her 8 seconds to catch up, and then both were going at 16 meters. They were both at 16 meters. Okay. Right here, you go over 5, 6, 7, 8, and at 8 seconds, she caught up to her, and they were both going 16. They were both at 16 meters. Does that make sense? Here they are after 8 seconds, and they're both at 16 meters. All right, so somebody read C for me. Aria, could you read C? Page 76. Thank you. We appreciate your assistance.
The winner of this heat will race in the final big race. If the race is 20 meters long, who won? Use both the graph and the equation to justify your answer.
Okay, so what did we come up with? Who won?
Leslie.
Okay, thank you, Aria. Yeah, sounds a lot like Garrett, but thank you. Yes, Leslie won. And what indicates on the graph that she won? Yes.
So you just skip
A is the graph. Okay, A is the graph, guys. If this makes you happy, here's A. There we go. What? Yes, right back here, Michael. Yes, the line is steepest. Leslie won, and we can tell by the graph, her graph is steepest. Very good. And what tells us her graph is steepest? I'm looking for one word. Yes, the growth rate. Very good. Graph is steepest, growth rate greatest. Okay, and what is another word for growth rate?
slope.
Slope. Very nice. Growth rate greatest. Slope greatest. That's very good, guys. All right, let's look and see what D says. D. Let's see. Ray, could you read D for us, please?
Yeah.
Thank you. D is page 76.
How long did it take each participant to finish the race?
Okay, so how long did it take Leslie to finish the race? I think they said they finished at 20. Okay, so how long did it take her to finish? Yep, 10 seconds, very good. So Leslie, it took 10 seconds. Fast race, right guys?
Mhm.
How long did it take Evie?
12.
Well, where is Evie? Oh, there's Evie. Yeah, I would agree with that. Okay, so let's go ahead and look and see. It took, where's Evie? We're at 20. Oh, we're at 20s right here, guys. Maybe 11 point, what do you want to call it? Well, it's not quite 5, but I'll take it. Maybe 11.3, do you want to say that?
Sure.
So, who is that, Evie? Yes.
I'm trying to get down to the highest number, which is 11.
Okay, you just rounded. Okay, so Evie, took
No.
approximately, I'll say that then, approximately, sure, 11.3 seconds. All right, so let's see what happened with Kristen. Where's Kristen at, guys?
30 seconds.
Yeah, she's at 30 seconds.
No, she's at 29.
No, she's at 30.
Nope, she's at 30 seconds. See that?
Yeah.
Yeah,
30
well,
seconds.
yeah, she's a little slower, isn't she? So, okay, so Kristen, let me fix my eye there. Kristen took 30 seconds. And let me fix my 0. All right, so Kristen took 30 seconds, so we've evaluated that really well. Let's go ahead and see what, is there anything else they want us to answer? Oh yeah, E. Who wants to read E for me? Okay, Garrett, read E.
The school newspaper wants to report Christian's speed. How fast was Christian writing? Write your answer as a unit rate. That is a rate which a denominator of 1.
Okay, so how fast was she going?
30 over 1.
Ooh, careful, Kristen, she was going up how much? Good, 2 meters every 5 seconds. So we can say 2/5 meters, this is a unit rate, 2/5 meters every every second. We'll just put 2/5 meters per second. That's it. I'm starting to write it all out, but we're not going to. 2/5 meters per second, or you can say, or 2 meters every 5 seconds. That's exactly what that's saying. That's exactly what that's saying. Okay? All right. So now we have done 52. Here's what I want us to do. This is a good foundation of what you're about to be doing in your teamwork. We're going to spend a fair amount of time in your teams. What I want you to do, wait to get started, please. You're going to do 53 and 54 in your teams. We're going to pull it back together and do 55 together. But right now, you are in your teams. All right, so everyone on page 77, yes? Page 77, an equation from this. Leslie, what would her equation be? Y, okay, we know that our format is y equals mx plus b. So what is her slope? What is it, guys?
2 over 1.
Good. So Leslie, and she starts at what? Okay, Nico, wait up here.
0.
Yeah, she starts at 0. Okay, so y equals 2x is all we have for Leslie. If you want to put 2x plus 0, that's fine, but it's really not necessary. All right, so let's go ahead and look at Evie's. I guess Kristen was next. It really doesn't matter. Okay, so Kristen, what would hers look like, guys? Y equals what? So she went up how many?
2 over 5.
2 over 5. Okay, so y equals 2/5 x plus what?
8.
Okay, good. Plus 8. Very good. And then last but not least, let's go ahead and write Evie's. And Evie's is what? Y equals what? How many did we go up for her? Oh, I just wrote them backwards in color, didn't I? I don't want to confuse anyone. I'm going to write that.
No, that was right.
That was right?
Yeah, that was right.
Oh, me bad. All right. Yeah, you're right. That is a more gradual one. So, yep, Kristen. Okay, so y equals, we said 2/5. Yeah, that's right. 2/5 x plus 8. All right, and then what's Evie's, everybody?
Christine.
What? Okay, how many did we go up for Evie?
Like 5.
And then over?
4.
Good. Okay, so Evie's was 5/4 x, then plus what?
6.
6. So is everyone clear how you write those? We know this is our slope, this is our growth rate, and this is our y-intercept. So here's the y-intercept, of course, we know is the starting point. Yes? Okay, great. Yeah, go ahead and get started in your teams on 53. Let's evaluate on 55. Erased. All right, so Ray, go ahead and read 55 for us, please. Read 55 for us. Thank you.
The president of the line factory is so impressed with the work that you have been given a special assignment. To analyze the graph below, which was created when a customer walked in front of a motion detector. The motion detector recorded the distance between him and the customer.
Okay, and then read the next part.
Attend a lesson 2 to resource page. The graph is
Which is this graph in your book?
the piecewise graph.
Shh, wait a minute. Ray has the floor. Read that again.
Number what?
Read again.
The graph is a piecewise graph. A piecewise graph is a graph that has different equations for different intervals along the x-axis. Working with your team, explain the motion that the graph describes.
All right. Well, let's look at this and see what's going on. So we can see we've got a few things going on, and it tells us this is our distance in feet, and then this is our, well, it should be up here, but it's not. Let me put it up here for you. Time in seconds. There we go. Our time in seconds. So same as what we've been doing. We have our distance on our y-axis and our time on our x-axis. And we see here, our detector is down here. Detector. There we go. Our detector is down there. And here we start. So, who's this person? Oh, just a customer. All right. So the customer is starting how far away from the detector? 5 feet. Good. So the customer is 5 feet away from the detector. And we see something is happening between 0 seconds and 4 seconds. We can call this, if we want, our first interval. This is our first interval. And let's evaluate what is happening. Is this a negative or a positive line on the first interval? Definitely negative. So this is falling. So this person is going down 1 foot and over every 4 seconds. All right, so we can go ahead and that's what's happening in our first interval. So if we were to write an equation for this, what would this first interval equation look like? I'll put it right here. What would that look like, guys? We know we have our formula, y equals mx plus b. So y equals what? What's our slope? Negative what? Negative 1 what? Yeah, good. Okay, negative 1/4 x. And then where do they start again? Good. So plus 5. All right, so that's the first piece. Oh yeah, let's look at our second piece now. What is this customer doing? They're moving at a very slow rate away from this detector. A very slow rate. Now let's look at it between here, and we'll call this our second interval. What do you think they're doing? They're very good. They're standing totally still. All right, so second interval, they're standing still, and when they're standing still, what do we have? They're at what? What?
4 feet away.
Yeah, they're 4 feet away. Very good. So y equals 4. We know this is a horizontal slope, and horizontal slopes have what? What's their slope? What's the slope of any horizontal line? 0. Very good. Okay, now let's look at our next interval. And let's see what's happening here. He only stopped for how many seconds? Or the customer did, he or she? 2 seconds. Good. So now we have between 6 and 9 seconds. We'll call this our third interval. Okay, and what is happening in our third interval?
They're walking away.
Yes, they are. At a fast rate or a slow rate? Transfer? Yeah, I got it. Yeah, at a very, very fast rate. So let's go ahead and write that. What's our slope, guys?
Over 3.
Yep. So is this a positive or a negative slope? Nico, is this positive or negative slope? Absolutely. So you go up 1, 2, 3, 4, 5, and so up 5 and over 3. Good. So we know that our slope or our rate of growth is 5/3 x. And now here's the tricky part, guys. We're going to have to take our straight edge because we know that this plus b is our y-intercept. So you're going to take this and you're going to have to draw it, extend your line so you have an idea of where it's crossing that y-axis. All right, so if it's down here, this is 5. There, I'll just use from here to here. Okay, so this puts us at -6. Okay, so what is there? What's this right here?
-6.
Yeah, -6. All right, so that's what the equation is. But of course, it's this is how the customer is continuing. So right here, he's walking very, very, very slowly away. He stops. He's looking around, or she is, and then all of a sudden they decide to just hoof it and take off. Right? So my questions for you guys is, how is the growth rate or speed represented? It's represented by what? The slope. Very good. Very good, the slope. All right, and then what is the growth rate represented by? As far as the letter goes in our equation?
B.
Growth rate?
Oh, wait, no, M.
Definitely M. Very good. All right, and then how does change in speed affect the slope of the graph? How does the change in speed affect the slope of the graph?
If you're going faster, it's steeper. If you're going slower, it's not so steep.
Exactly. So the more positive or more negative the graph, the steeper the graph, the faster the individual in this case is going. And then how do we determine the equation of a line from a graph? What do we look for? We look for what? How do we determine, if you're given an equation, what does this tell us?
That you're going down one.
Yes, this is how fast or slow the individual is going, and this tells us where you start. This tells us our starting point. Very nice. Okay, what I'm going to do now is I'm going to go ahead and hand out your homework, and you have the last 10 minutes to go ahead and get started.